Hello friends, in this video I'm going to take question number 15 of exercise 9.4 of Ncert Maths textbook class 12 from the chapter differential equation. Okay, so friends, the question is like this: find the equation of a curve passing through the point 0, 0, that is origin, and whose differential equation is given by y dash is equal to e to the power of x into sin x. Okay, so it is quite clear what is said in the question. So let us start solving the question. Now friends, we have been given the differential equation for which we have to calculate the equation of the curve, and we have been given a condition that the curve passes through 0, 0. So first thing what I can do in this question is that I can write y dash as equal to dy by dx, and I can separate the variables. So separating the variables, I can get dy as equal to e to the power of x into sin x dx. Okay, now variables are separated, so now I can integrate both sides of the equation, and I'm going to obtain integration of dy is equal to integration of e to the power of x into sin x dx. Now integration of dy would be equal to y, but this integral, it contains two functions, that is, it is in the form of product of two functions e to the power of x and sin x. So this would be solved by integration by parts, and to add, the calculations are lengthy. So what I'm going to do, I'm going to solve this integral separately. Okay, so to solve it, I take the given integral and I assume that this integral is equal to I. Okay, and further I can write that the given integral as equal to integration of sin x into e to the power of x dx. Okay, now I can apply the formula of integration by parts by taking sin x as first function and e to the power of x as second function. On applying the formula, I get I as equal to first function into integration of second function, that is sin x into integration of e to the power of x, minus the integration of the product of differentiation of first function and integration of second function. Okay, now integration of e to the power of x is e to the power of x, differentiation of sin x is cos x, integration of e to the power of x is e to the power of x. So I am going to obtain here e to the power of x into sin x minus integration of cos x into e to the power of x dx. Now again, it is in the form of product of two function. Now I'm going to apply again the formula of integration by parts. So I'm going to get this term as it is. Now this would be equal to cos x into integration of e to the power of x, that is first function into integration of second function, minus the product of differentiation of first function, integration of second function. Okay, quite clear. So differentiation of cos x would be equal to minus sin x, integration of e to the power of x would be e to the power of x. So I'm going to obtain the expression like this: cos x into e to the power of x minus integration of minus sin x into e to the power of x dx. Okay, so this minus minus is going to become plus, and on opening the bracket, I'm going to get this as equal to sin x into e to the power of x minus cos x into e to the power of x minus integration of sin x into e to the power of x dx. Now if you observe this value, integration of sin x into e to the power of x dx, so this value is the value of I, that is the original integral from where I've started integration. So this value can be replaced by I. Okay, this I is going to go here, and I'm going to obtain 2I as equal to this value, or I can write I as equal to 1 by 2 times e to the power of x into sin x minus cos x plus c. Now on placing the value of this integral and writing integration of dy as equal to y, I get this expression. Now the question said that we have to find the equation of the curve. Okay, so this is the general equation of the curve. Now if we have to find the equation of the curve passing through the point 0, 0, so this means we have to find a particular solution for the given differential equation. So we are going to apply the condition. So for that I mark this as equation number 1, and as the curve passes through origin, I place x is equal to 0 and y is equal to 0 in equation number 1. So I am going to obtain 0 as equal to 1 by 2 times e to the power of 0 into sine 0 minus cos 0 plus c, or I am going to get cos 0 is equal to 1, so I get minus 1 inside the bracket, and minus 1 into 1 by 2 is minus 1 by 2. So this gives me c is equal to 1 by 2. Okay, now placing the values of c in equation number 1, I am going to get y is equal to e to the power of x into sin x minus cos x plus 1 by 2, or I can write 2y is equal to e to the power of x into sin x minus cos x plus 1, or 2y minus 1 is equal to e to the power of x into sin x minus cos x. So this is the required equation of the curve. Okay, so this is how I'm going to solve this question.
Friends, thanks for watching my video. To watch more of these super videos and for the latest updates, subscribe and like the videos on these channels on YouTube, HSK Shiksha and Math Help by HSK. Thank you.